This is our chemistry application media project for colligative properties. My name is William Watson.
I'm Sydney Young.
My name is Carter Wells.
And my name is Rodrigo Aguilar.
So the goal of Colligative Properties Lab was to identify an unknown compound based on the calculated molar mass and observed physical properties. The molar mass was determined from the measured depression of the freezing point of the solution.
The colligative properties of solutions are properties that exclusively depend on the concentration of a solute and not its identity. A freezing point depression occurs when a solute is added to a pure solvent. This is because the solute interrupts the pure solvent's ability to freeze properly, and therefore it takes a lower temperature to freeze the new solution.
We determined the molar mass by finding the change of freezing point depressions between pure water and water of the unknown, then using the following formulas to calculate it. We will calculate the molality by dividing the change in temperature by the water's freezing point depression constant, which is 1.86. Then by multiplying the molality by the mass of water, used in kilograms, we determine the moles of the unknown solute. Finally, we divide the mass of unknown by the moles of the unknown solute to find the molar mass.
The experiment we conducted involved measuring 15 milliliters of distilled water and measuring its mass. The water was then placed in an ice bath, and its temperature should have been recorded every 10 seconds until after the temperature change reached zero. These findings were then meant to be compared to the three following trials in which 2 grams of an unknown solute were mixed with the same amount of distilled water, and the solution's temperature change was once again recorded through the same process.
So after the experiment was conducted and we recorded 10 data points for each of the three trials in the pure solvent, we found that the freezing point of the pure solvent fluctuates around 0 and 0.5 degrees Celsius, while the solution with the unknown has a freezing point between negative 1.3 and negative 1.5 degrees Celsius. So this is just proving our background, which the freezing point depression uh, that's occurring in the unknown trial occurs due to the colligative property, which shows more solute molecules present in the solution will decrease the freezing point.
Based on the data we found, we determined that trial 1 had a temperature change of 1.29091 degrees Celsius. Trial 2 had a temperature change of 1.74907 degrees Celsius. And trial 3 had a temperature change of 1.72445 degrees Celsius. As for the mass of the water, we had mostly a similar mass of water for all three trials, with the first trial having 1.49696 times 10 to the power of 2 kilograms. Trial 2 had 1.49908 times 10 to the power of -2 kilograms. And trial 3 had 1.53837 times 10 to the power of -2 kilograms. The mass of the solute was exactly 2 grams for all three trials. And after calculating, we found that the molar mass of the solute for our first trial was 193 grams per mole. For our second trial, it was 142 grams per mole. And for our third trial, is 140 grams per mole. On average, this made up 158 grams per mole for the solute, with trial 1 being the outlier out of the three molar masses.
So after our average was calculated to be 158 grams per mole, we decided that our unknown solute was most likely glucose, since the molar mass of glucose is 198.17, which is the closest to the molar mass that we found for our unknown.
And once again, that was our camp project. Thank you for watching.